Yes, hello. Hi, everyone. Welcome to another episode of Amplifying F Sharp. Let me start off by sharing my screen and walking you through our typical introduction. We are Amplifying F Sharp. This is an initiative to have more people working on the F Sharp ecosystem, specifically in the open source space. What we are trying to do is encourage people to really dive in, chime in, and learn how to contribute. We have a couple of initiatives going. One of our latest initiative is the F Sharp Essentials lecture, which is a series for existing programmers that want to pick up F Sharp, which is a thing that happens every week. So definitely check that out if you just want to learn F Sharp. If you're already familiar with F Sharp, we just try to organize these kind of sessions to learn something on a specific topic. So for example, the F Sharp compiler or various other things inside of the ecosystem. If you're interested in having a session about a specific topic, we definitely want to facilitate that. And truth be told, the well is kind of running dry. So we really want to encourage you to click this Join Us page to write up what you're kind of interested in hearing. Or if you just want to speak about something cool in the F Sharp space and just want to promote something, we really would be happy to have you. Just let us know and we can sort of set up a session like this. From last week's session, Edgar was working on the F Sharp compiler. And a follow-up on that is that the PR was raised. We found something in the attribute usage, and it sort of led to a PR, which is now under review for from the F Sharp team. So that's definitely a good start, and I'm pretty sure that we'll be able to work that way too. As for today, I've been kind of looking forward to this for some time now. I've been working on something called the Vite plugin for Fable, which is what the session is going to be. And yes, let's just dive into it. I made a couple of slides, and today's agenda is just a little bit about what this is, what Fable, what Vite is for people that are unfamiliar. Then a little bit about why creating this plugin, showing off the plugin in a hello world scenario. And then to wrap up, we'll talk a little bit about how the internals of the plugin work and what we should do to potentially add script support and just give a bit of an overview of how everything works. So if you've never heard of anything besides F Sharp, Vite is what we consider a dev server. It is a web server which you can spin up on your local machine and where you can serve your HTML, CSS, JavaScript. If you make any of those changes, it's reflected immediately in the browser, and it's really a really wonderful tool. Fable is a way to transpile F Sharp source code to JavaScript. The way you can currently combine two worlds is by running the .NET Fable tool. So that is a .NET tool which you invoke with the watch commands. Typically, you want to say, hey, Fable, start compiling my files, watch them if they change, and then recompile them to JavaScript. And then there's this -- run npx Vite, where you basically want to say that every time something did compile or after the initial compile, you want to start a Vite process, which then acts as the dev server. Now, my biggest issue with that is that I don't think that should be the developer experience. Yes, you are all wrong. So I basically think that we should follow what Vite does. You're starting the Vite dev server. That typically is going with npm run dev because that's what you get scaffolded out of the box. And that's how Fable should hook into that. To be fair, Fable does exist a little longer than Vite. I think Vite is about 3 years old, and Fable predates that. So it makes a lot of sense that you can just run any process after Fable has watched the files, but that doesn't mean that I need to agree with it in today's world. So again, recapping, Vite just is a lot bigger than Fable. So you really want to let Fable fit into the Vite universe and not let the Vite universe resolve around Fable itself. So I really think that the entry point matters. You want to hook into that larger community that's it's just a lot more present in the front-end space. The developer experience should be similar. Another thing that really bugs me with the way you currently are advised to do it is that all the transpiled JavaScript is written to disk. I don't feel like that's necessary. It could all still just happen in memory. And I would just like to import my F Sharp file, not the transpiled, but just the raw.fs. And that's sort of where this plugin comes in. In Vite, you can configure plugins in your Vite config.js. There we will see in the demo how we can set that up. The Vite plugin itself is two parts. So the plugin is in JavaScript, but then it's going to communicate to an external process because let's still face reality. Fable is a .NET tool. You're in the .NET world. So if you want to bridge those two, you'll still have to run them in separate processes. And to communicate between them, we're going to use JSON RPC, or that's at least what the plugin uses. But that's more or less in a nutshell how that works. Before diving into the demo, Bun, have you heard of Bun? Bun. I use Bun. I'm going to use Bun in the demos, but you definitely don't use Bun. But I just really, really wanted to let you know that I use Bun. So that being said, let's go to the demo. And I'll just start from scratch. Hope the font's okay. The first thing we're going to do is call bun create Vite. That is similar to how npx or npm create works. It just basically is going to scaffold our Vite project, which we'll just call AF demo. We are going to select React because we'll have a demo with that, and just regular JavaScript. So if we go to the AF demo, we will see that it scaffolded everything you expect from a Vite project. So this is a package JSON, the Vite config. I am going to assume a little bit that you have ever played with Vite and then sort of more see the difference of the existing experience versus what's already happening. We are going to install the Vite plugin inspect. So that's not strictly necessary, but it's going to be interesting to see how everything works. Then we are going to install the Fable plugin, which is what we're trying to illustrate. And because I'm using Bun, there's a couple of things that doesn't work on Bun. I'm actually using Bun on Windows here, which is just a canary build. It's not even officially released yet, but I just can't help myself. And one of the things that will bump into is that the post install for a trusted npm package is not yet run. And the Vite plugin right now does require you to run the post install script of the downloaded node module. So this is strictly like a Bun thing on Windows. And what this will do, the post install hook is actually going to compile some F# code, which will create a binary that's then later used in the process, in the plugin to spit up the .NET process to really communicate with the .NET side of things. Okay, lastly, I will scaffold some basic F# files. So I have a little helper script on my local machine, like this new Fable thing, just runs a bunch of .NET CLI commands. We create a new manifest, we install Fable, we're going to use Fable React in the demo, and we just scaffolded like a new app fsproj. Let's just look into code what that means. So let me bump up the font. Very simple stuff. We just have a project file with a single file. It has some NuGet packages. We have some F# code that will just do a console log. That's how you would do that in Fable. And we will need to configure our plugins. So I imported the inspect plugin. So from Vite inspect, we'll just add that as well. Import the Fable plugin. The order does matter a little bit. And that is going to be good enough for now. We are just going to hit bun run dev. I almost forgot. Another little bun thing, like we want to use bun inside the script, so we'll have to prefix that as well. Basically, when you do like a bun run, it's going to run the script, but if you just put in Vite, it's still going to do things in Node, and you still want to use bun, so just go with it. But yes, this is what we are after. Let me try and zoom in there a little bit. Okay, that's a little bit usable. Right, so we spun up our local dev server. We can see that we have a Vite and React. We'll now try and use our file. So we're only logging like to the console. So let's just do an import from that app.fs. Let's save the file, and you can see that it works. So I think that's pretty amazing. Again, proving that this really works, let's just change the text, and the browser got immediately refreshed and the console log was out there. If we take a look at the inspect command, so from that inspect plugin, we can see what happened when a file was trying to be imported. The first thing that happens is it loads the F# content. Then the Fable plugin will have transpiled that using Fable compiler inside of the .NET process to actually get the JavaScript. And then no further, well, the import analysis adds a stamp here, but that's about it. And you, yeah, that's how the file was eventually being served. So that is a cool first little demo. Let's change this code to be a React component, probably. Okay, I want to zoom in a little bit. So I still just very much like Fable React with like the DSL with two lists. That's never really going to change for me. But we are going to use the attribute React component from the Felice compiler plugins, and that will transform this whole thing to the transpiled JSX call, which will be like react.createElement kind of thing. And we can use that in the plugin ourselves. Of course, we'll need to tweak things just a little bit because there is some magic in the React side of things that we need to take into account. One of those things is that React needs to know that the JSX runtime is classic, because that's pretty much what the compiler plugin will generate. There are two flavors of JSX without going into detail, and this uses the old flavor. So we just need to tell Vite that the old flavor will be used. And we will also need to put in a regular expression to tell Vite that it needs to wrap components with fast refresh coming from a .fs file as well. So these are just basically ways of telling Vite that either JSX or FS files should be wrapped with the fast refresh thing. And the fast refresh is the thing where you edit your file and the browser doesn't fully reload, but just updates the changed React element. So I think I have it, although one thing I probably want to take into account, when using this old JSX form, the classic, you need to put in import React or something from React. That was just something you had to do. And by default, the Vite plugin, sorry, the Vite create, so bun create Vite scaffolded things according to the new world. And I just need to add this little import statement because we're doing things with the old word. Anyway, if I run bun run dev again, I very strategically for the demo, so I stopped my server, edited my config, and then restarted it. So full disclosure, that's, it probably won't pick up everything if you start changing the config and restart properly. So yeah, not gonna lie, that's a bit of a thing. This tool definitely, the plugin, it still isn't perfect, but it's definitely in a state where things can be presented. Now, I'll just import the foo component from my app.fs. I'll add it after the app component, and then you see hello from Fable. If we look into the inspect, we'll see that it's loaded the React component. Fable plugin transpiled it to react.createElement. And then the React components, or the React plugin for Vite, then wrap this in fast refresh. What that allows us to do is, if we were to go back and change the text to hello there, then it automatically updates it. But the more impressive thing is that if we're introducing some new state in the counter, and if we save now, like the count 6, the number of times I clicked is still, that state was preserved, even though my other component changed, which is really the drop the mic moment. So yeah, this is very cool, and this works to some capacity, but it is also very fragile. Like the way fast refresh works, it can easily be interrupted. If I were to add like a sum a b function and not even use that, try to count again, like you see the count was already 0. I save it again, like, oh, it doesn't work anymore. And that's because you can only have, like, the function component can be the only publicly exposed thing. And if I put in a private here, try that again, then it works again. So it's a bit of a yeah, brave new world. There are a lot of things that you should take into consideration when doing this kind of thing, when fast refresh still works or when it doesn't. There are rules to that. Those apply. You know, this is not really an F# or Fable thing. This really is more like a how JSX works thing. But nonetheless, it's kind of impressive that this works. Notice that we just don't have anything on disk here. And yeah, I'm pretty excited about that. Fable can also produce JSX. So if we try more or less the same thing with the JSX helper function, just fit that on the screen. So inside of the more later versions of Fable, this can be picked up by the compiler and then JSX will be created. But because JSX is created, Vite needs to it needs to be transpiled, and we'll need to tell the plugin to actually do that. So if we tell the plugin to use the automatic, which is like the new JSX style, the plugin will run ESBuild similar to how Vite were to do it, because that was a bit of one of the confusing parts. You would think you have a React plugin, so that is the thing that transpiles your JSX, but that's not really the case for the new JSX. So yeah, little thing to be aware of. We are probably good to go. Let's try that. And then we have new JSX stuff here. Notice that the font is a little smaller because we went with an H2. Okay, H1. Good stuff. So I believe this will still work. There we go. And if you look at what's changed, the plugin now created the JSX, and Fable sort of did the job until you actually have the JSX syntax, and then ESBuild transformed it to this new JSX with the JSX runtime. That's sort of the new way JSX is being produced. And again, you want to play ball with the larger ecosystem. A lot of people use either Babel or ESBuild to do this. Vite uses ESBuild, so that's really the world we want to hook into. Cool. Going back to the slides. So about this project, I recently went to FOSDEM and I saw one of the talks that was going like surviving to thriving in open source. It was a very interesting take on open source, not just because you have a good idea and you put it out there. Does it mean that's a good thing for people to start using it? So I just want to be very like upfront. What's the sustainability plan of this project? Well, there is none. This was a passion project. I'm very excited about this. I'll update this until my own use cases work with this. But other than that, it's Apache 2. The code is out there. You're able to reproduce the artifacts. So yeah, take that into consideration when exploring this project. I will accept pull requests if any good one comes in. But right now, I just do not have the mental capacity to deal with like maintaining this or putting any claims that I'll maintain this forever. That's why I decided to not put an issue tracker on this. I'm very excited about it, but like I said, this has all been spare time and late nights that I work on this. So yeah, I'm just gonna put it into this place with a good disclaimer that, you know, be aware of what this is. If you really want to have some sort of support, I do provide professional services for a living. We can always talk. This is not really my idea, but this will be a little bit similar to, not be similar to how Phantomus is maintained. There's a little bit of lessons learned. I put this project out there. I really like it, but I just do not have like more energy or will to, go much beyond that. So just that we're all on the same page. All right. Creating this plugin on a technical level required provided a lot of challenges. I would like to thank two people in particular for that. Maxime from the Fable side, because what happens now with the Fable CLI tool, I had to extract the bits that are interesting to use in the plugin, and I sent a lot of PRs to the Fable repository for that. Maxime was happy to review and accept them, even provide published releases for me for my little experiment. So I'm very grateful that he's on board with me trying this. Then writing a Vite plugin was also rather tricky. There's documentation, but there's a lot of questions that you will have when you dig into this. And I don't really have any friends in the Vite community. So when I was really, really stuck, I just asked people, hey, how does that work in Vite? And I'm just grateful that Patak was able to, he's one of the core maintainers of Vite, that he was able to answer some of these questions that I had. And it really had these aha moments for me that really clicked. All right, and now let's take a look at what it would look like to add script support. Before going into that, let's also there is a bit of documentation for this plugin. Like, I do try to help future me in getting, remembering how I got things to work. So there's a little bit of context how this works, how Vite talks to .NET. If anybody does want to get into it, I definitely encourage you. But there are some technical implications that, yes, there's the plugin side, there's JavaScript, there's .NET over here, you need Fable compiler. Like a lot of things, I just had to use my own local Fable compiler to introduce something new to solve a certain case inside of this plugin. Then I also even had to take a look at F-sharp's an Encase F-sharp fork, because I kind of want to expose something from that. And, all of this is to say that it is kind of a technical, complex project. I don't mean to over-engineer it, but there's just a lot of moving pieces in trying to bridge those two worlds. So that, again, just puts in a little bit of context why I don't have the energy to answer to you if something little doesn't work. I really have to go down this entire stack rabbit hole to really get what's up with that. So that being said, there are a couple of things you can configure. If you don't specify any F# project file, it will just look into the same folder and try and find one next to the config. You can specify the main project yourself. And then there's the recipes for the things I just showed you, which was like the classic JSX and hot fast refresh if you use the compiler plugin. Or if you use the new JSX, then you need to have it transformed by the plugin itself. The current status, I published it. It works on a couple of projects of myself. I'm still looking into fixing a lot of things with some projects where it doesn't work. I'll work on this when I have some spare time, and everything else, I try and encourage you to contribute the missing pieces yourself. Because that's a little bit the state of affairs right now. Okay, so let me open the solution. Now the key thing is that the main file is this index.js, which has a default function, which is our Fable plugin. And there are a lot of hooks, and when Vite is loading your plugin, it will just call these hooks at the appropriate times, and that's sort of where everything comes into play. In the beginning, somewhere over here, yes, we have an endpoint. We are basically going to spawn a .NET process. Like I did that little thing with the post install. And I said, oh, bun doesn't do that. Well, if this post install is run, it actually is going to do a publish of the Fable daemon. So that's like a command line tool that's just a process which then is connected with JSON RPC. And I'm actually shipping not the binaries inside the npm package. I am building the source code on your machine. So that's kind of what happens in this post install. Why am I doing that? Because I wanted to publish this ready to run. But if I want to publish something ready to run, I either publish it for every known target, which ends up with a lot of binaries that you're not using, or I can pass in this flag, which will use your current runtime to do the publish. So basically, I am on Windows here. If I were to run this thing, it is going to do the .NET publish. It's going to create the, in this case, Fable daemon exe, but I'm accessing it from the DLL side. And that's sort of to connect to the .NET world. So things like that, I'm still not quite sure, like, is this the right way of doing it? Should I ship the binaries anyway? Like, there are pros and cons to it, but right now this seems to work for me. The moment a Vite plugin, the first hook that is going to be called is the config resolve. That's like when Vite configure has loaded all its configuration. So if there's other plugins that also have provided configuration, then it also comes combined in this resolved config. In the resolved config, I try to figure out is there an fsproj file? If there's not, I'm going to try and find it. This find method just really looks into the same folder. And currently, if there is no fsproj file, I'm going to error, because that's the assumption is that you just now have a main F# project file, and that's the initial starting point. When a build starts, that's the next hook that's being called. We just first try and compile the project. The compile project is eventually going to, it tries to find Fable library. It is going to get the project file. And what that hook does is it sends a RPC, it calls an RPC endpoint project changed. If we then go to the command lines tool of things, there's going to be a matching RPC endpoint. It gets the payload. I use a mailbox process because there's like multiple messages and some state that's being maintained. So the project changed will be over here is one of the things in the mailbox. It will try and type check the project and then just give the results of that. So from this like app fsproj, we kind of need to know what the compiler options are, because the F# compiler will eventually need those. And we're going to see, are there diagnostics? So yeah, this is really the more low-level stuff. We'll need to give the correct Fable arguments. We'll need to do the cracking, the interactive checker. So that's Encave's F# work, which works a little different than the F# checker that we've seen in other sessions. And yeah, then it does the type checked project. I also try and find the dependent files. So what files, if they change, I need to like update the whole project. I need to recompile the entire project. For example, if a project file is getting some inheritance by like MS build stuff and then uses the directory build props, if that props file were to change, then it could potentially lead to different compiler arguments. So you need to do the whole recompilation. So again, all good stuff. These endpoints are called from time to time. And once that then happens, the build start has the initial compile. After the initial compile, I am basically going to have a little bit of state here where, yes, plugin state, gonna go to that. We're just gonna, the files that are already compiled will then be accessed in the transform callback. So when your Vite server is running and all of a sudden you request a .fs file, we can hook into the transform. The transform hook can hook into that. We'll just test, is this an F# file or not? And if it is, then we'll just try and find, hey, is there any of my compilable files that has this? And if it does, we can just get our previously cached results and return that. In case of JSX, like I told you, we still need to do it ourselves, which is the transform function that comes. Oh, yeah, that's like being imported from ESBuild itself, which still does that. So that's a little bit of a config. Yeah, you can see source maps are not supported for now, but it's not impossible to have those. And then, of course, when a file change has been detected, we check, do we have the project options? Is it one of the dependent files, or is it just an F# file? If it is an F# file, we're just trying to target the compile endpoint. And if we go back to program, the compile endpoint, the interesting thing here is that if one file has changed, potentially multiple files have different JavaScript output. So we need to detect that as well. And if we try and compile that, the return type of this thing will actually be a set of compiled files. And that compiled files is just like path to JavaScript. But we just want to tell Vite like all these files have changed when maybe a single file changed. Now, the file change that's being processed, that's all well and fine, but that does not trigger the browser reload yet. So that's where this last hook comes in, the hot handle hot update. It will basically try and see, oh, this file changed. What does that mean? What modules are compiled? Yeah, this was one of the more complex stuff, but I basically have to figure out inside of the server graph what modules are now affected and potentially push those. And then over here, you're going to use WebSockets because that's how Vite communicates these changes. Send a event that this changed, and potentially it only will hot reload your React component like we saw, or if it just can't deal with that or their dependencies, or you're doing something that triggers a full browser refresh, then it's just going to do that. So that in a nutshell is how that works. And for the remainder of this time, I just want to give people an idea how would it look like if we just had a script file over here. So if I add, let's say script.fsx, sure, why not? Then do like a NuGet Fable core, open Fable.core, do a JS console log, hey, from ripped, because this is nice. Sometimes you have something where you might want to do a little piece in F# and you don't necessarily want to have and a source file and a project file and all those other things that come with it. You might just want to have it all in one go. So that's where I'm kind of interested in having a script file. The interesting thing I want to try eventually and migrate is we have this submit a session page on our Amplifying F# website, and that now uses little JavaScript. We got some remarks from the community that were questioning like, hey, why is that site actually built in Astro and not in F#? Well, I like Astro. It's okay to like different things, but you know, as sort of a compromise, it seemed cool to have a little script, Fable script inside of that Astro, and then Astro uses Vite under the hood, so potentially the plugin works there as well. And that's sort of the journey we're on to try and get this running. We will take a look at the index HTML. One thing that's a bit of a limitation is I need to import F# files or custom files, because you can do this in regular JavaScript where you say foo.js, like import that file. The browser understands that, but it's not like an official agreement that a browser should think you're able to do this with other file extensions. So that's a bit of a current limitation to Vite. And you just need to import it like you would import inside of a script block. So what we're going to try and do is import FSX. Let's just naively go to that sample application, which is a bit of a testing ground. Let's do a run def, and we'll immediately like hit a wall. So yes, there's a port in use. Let's try that. And then you can see that it has a syntax error for scriptfs. I probably don't have the inspect plugin here, so that's something we can still add. And yeah, I actually don't really need to React one right now. So let's try and save that. Restart it. This still doesn't work, but let's try and inspect why. And you can see that the only thing, let me try and get that a little bigger. The only thing that happened was the import analysis and the load step. So there was nothing really reacting to the script FSX. So now it's going to be like an interesting take on how would we deal with that. Okay. So yes, buckle up because this is going to be pretty tricky to really get right. So I'll just give you an outline of what I would attempt, and then we'll sort of see what happens. First off, I'm probably going to comment out a lot of code. Like we are only going to import the F# script. We're not going to deal with the fact that the plugin is now expecting that there's a main fsproj file. Let's not deal with that right now. So basically, we don't care about the build start. We'll just transform the incoming, like if create a regular expression where we say if it ends on fsx.test ID, say console.log should transform like that. And let's not deal with file changes right now. Let's not also deal with like hot updates. So this session, I really want to, keep it light and give you an idea of how this somewhat works, and yeah, don't want to overload people with a lot of this because it is overwhelming, to be sure. I can also do like a run build, which is going to use the same hook. That is to create your build output. So we'll see that it says should transform. And a first good step is just to make the build work and then deal with how does a live server react to it. It uses the same callback hooks. There are subtle differences to what happens when you do the def versus the build script, but for now it's going to be good enough. So it tries to transform the index HTML. It said that it should transform, and then it just didn't do anything. What we basically want to achieve is something that says this is now the code. We had a console log of, what was it? Yes, this thing. A from scripts. If we run this again, then it was able to make the bundle. If we look inside of the dist folder, the assets over here, we should be able to find that hey, and that's the console log, and that is our bundle being made. Now we are going to try and actually get this transformed. And let's do everything just a little bit in line. So it should transform this thing. We'll call an endpoint that doesn't exist yet. We'll send that we want a Fable. Let's just do like Fable script for now. Send in a message payload, which is going to be the ID. And then we're sending things to the .NET side. We'll get a result, and let's just say the result needs some code. So I'm really skipping a lot of steps, but conceptually you understand what's happening. We're it's going to be very bare bones, but good enough for now. So we need something on the receiving side. If we go back to our program over here, we'll see that we'll need a JSON RPC member. Some stuff will eventually be able to be reused, but let's not focus on that right now. Let's not try and make this fit into the bigger thing. Let's just try and get that endpoint up and running. So use single object. That seemed to be the option I was after for the serialization. And let's say member dot file scripts maybe. So take in object. Yeah, that's kind of wondering if we're going to get away with an anonymous object, maybe. And then let's actually really try and cheat and put in just that similar buildup like we had. Like at the very least we're what do we have here?
Your message, not just the ID, not the source yet?
What did we do?
In line 315, you pass the ID, not the source?
Yes, exactly. Thank you. So we have the ID, which is going to be the path. That's fine. It's okay to access the file system inside of this .NET side of things. I don't really have any problem with that. From scripts, but from .NET. And we'll have to run the post install command from the folder above. So yeah, we do need to publish this file before it's going to be picked up for a sample project. If we now run build, I have some JavaScript problem. It says should transform. It's not quite. Oh yes. Results might not be what I think it is. Okay, results did have the code, so that's good. I am a little puzzled where. Oh, it's probably just a string. Yes, okay. I need to console log that. Yep. Right. So now the result was okay. The build was fine. I'll say .NET. So that all works. That's very fine. And the next thing we'll need to do is try and get Fable to compile this. So now the difficult stuff happens. We'll try and then do a little bit in line based on what the other functions have, but the Fable compiler NuGet package will now need to be accessed. And so if you look over here, we are using, okay, no, I did that slightly different, but we are either using the Fable compiler, or if there's not, if what we're after is not yet present in Fable compiler, we'll need to look into, just adding references to your local Fable compiler and changing the code there. which is something I'm kind of afraid of we'll have to do, because every little new area you want to explore typically leads you into, oh, we didn't think about that, or I didn't think about that in Fable compiler just yet. So that's a little bit of the downside of this project. It really jumps to different places. But yes, okay. Let's take a little peek about how it happens in Project Changed. So going through that Project Change, we'll do the try type check. So let's take a peek at what happens in try type check. And it's going to construct these CLI arguments where it is going to need cracker options and do a full build, create the interactive checker, have the dependent files. Wishful thinking, this actually just works with our script file. There's a very slight chance, so I'm not quite sure, but let's call that maybe. But to be fair, let's think about a result. So try and type check projects. The project in this case will be like the script file. Script file path. Now the ID we're getting is going to be a normalized path of Vite. So we actually want to get the full path in Windows fashion from that. So we'll try and create that as well. So system.io.path get propath. Yes, p.id. There we go. And yeah, that's sort of the subtle things between Unix and Windows. And you need to. Vite has this normalize function which it promotes of using. Like every time you're unsure, just call the normalize path function from Vite. But I've noticed that on the .NET side, it's best to normalize everything with the full path of the current operating system. So that's what we're going to do first in that program. Then the type check project takes in a cracker resolver. This is kind of to do the design time build. In this case, it's not going to do anything because the cracker resolver won't be used inside of the Fable resolver for scripts. How do I know that? Well, I just had to contribute a lot of the project cracking code changes myself, so I kind of already know that one. We'll have a payload project changed, which is going to have a couple of things. We'll try and hard code on most of them because it's really only the path that is relevant for us right now. So let's try and generate the missing fields. Configuration can just be debug. The project will be the script file path. Fable library, that is basically going to be inside my node modules. I have this at Fable.org. It is relevant for Vite to use this Fable library.js and not let it generate by Fable itself, because it can be cached and optimized a lot better with ES builds. So that's really why the preference is to have this. We are not going to exclude anything, so exclude is a Fable property that would be interesting if you are working on a local plugin, which is not what we're doing. No reflection is true because we don't really need any reflection code. And this is a weird state. Huh.
You already have a squiggly, you already have a curly brace at the end on 385.
Gotcha. Yeah, thanks. So payload. And it will be interesting to see if this already gives us something, then that already saves us some trouble in looking into the Fable compiler code. We're going to test this, but we're not really going to do a build, then run the tool, then see if we got anything back. That's yeah, not that super convenient to do. It would be great if we were able to debug this. So I made a little test project that allows us to debug this daemon thing without having to deal with like the Vite plugin side of things just yet. I'll just hard code the path to the script file over here. And let's just go to my little debug test. I'm calling the daemon over here. Let's remove that. And then we can say client dot something with scripts. No, okay, yes, daemon dot scripts file scripts, which has the ID script file and results. So wishful thinking, we'll be able to figure something out. Let's take the sample app for that as well. Because another thing about the JSON RPC is that, yes, that rings a bell. We cannot log anything to the console because it uses the standard input, the standard output from the process to communicate the messages. So inside of this thing and even inside of Fable compiler, we can absolutely not write to the standard output because that will mess up with the message that's being sent via the two processes. And yeah, that's another thing I still need to think about. What's like a good experience to debug this a little bit, to have an idea of what's happening in the .NET tool. Have some ideas, but didn't really come to much just yet. Let's try and debug that again. Okay, so the resolver, we have the payload. Quite curious. Like the cracker response, I kind of expect that at least to resolve the project options of the scripts. So the cracker response project options. So it tries the script project options. Okay, it has a bunch of other options. It has a bunch of default references. So that's all the stuff the compiler needs, which is pretty good. And that is basically, we're going to type check the project that came out of that. I'm kind of expecting that to work as well. So that's already a very good start. We have some assemblies, we have project check results. So we definitely have some good setup here for trying to pass this information to the Fable compiler. So the first step is that it takes the F# compiler things, then it makes Fable AST, and then eventually it makes JavaScript. So we're kind of halfway there. So that is good. And then wishful thinking, I can just say that I'm going to try. So we try to type check. There's also a method to compile a single file over here. And I hope I can just call that and maybe even call it a day. So try compile file. It needs the model. Yeah, it definitely needs some stuff. But maybe that can all just be reused. And if not, let's just copy stuff and inline it and let's say TC results, PS results, try compile file. So this takes in a model. So there's definitely some state involved inside of the mailbox processor. probably, can I already do the model new? No. I think that's coming in one of the next writer versions. So it needs the resolver, which we already created, the CLI arcs, which might be okay. This returns a result, but this result probably has all the things we're after. So let's just say that TC result is TC result match. Result value fail with to do, yeah, it's fine. And TC result, CLI arcs, TC result checker, tracker response, maybe. Source reader, so we'll need a source reader, which I'm not sure, it probably still needs to be created. Path resolver. Okay, there's no path resolver, and that requires the type project results. And I'll have to cheat just a little bit. What's the source reader? Let's just grab it. Source reader model. So Fable has like a different way of dealing with reading the source from inside of the fork. Takes the cracker response, so that would be TC results, cracker response source files. So basically, it is not going to try and read the file from disk. It's going to use the source reader to do that. I think this sort of predates what the in-memory source reading from the F# compiler did. So that's just a clever way of Encave to deal with that. So yeah, again, we're not using the F# checker, we're using interactive checker. Subtle differences. So we need the model over here, and then we need the script file path. We'll need the source read. No, we have the source read. Oh, sorry, the path resolver. The model path resolver. Where's that coming from? Dummy resolver.